Hello everyone. Today we will present the VIIV, the Value Investing Intelligent Vanguard, the LLM-powered stock analyzer for the Thai investor. We will start from the section 1, the ML model implementation. This is our ML canvas design. Next is the model training implementation. We began by loading a Thai language instruction dataset in JSON format. Each record includes the user question, additional context, and the expected answer. We run exploratory data analysis or the EDA to understand the instruction and output range, detect anomalies, and ensure balance. For the data preprocessing, we format the data into a special chat style prompt using IM_start and IM_end tags. The input was tokenized using the model tokenizer with padding, truncation, and masking applied to allow correct training behavior. For the model architecture, we use the auto model for casual LM class with the OpenHiGPT 1.5 14 billion model. To reduce memory use, we apply 4-bit quantization with bit and bytes config. For fine-tuning, we use LoRa, which modify only key attention layer like Q-port, V-port, K-port, and O-port. For the training loop, our training pipeline used the SF3 trainer from Hugging Face TRL library. We experimented with different LoRa rank, alpha, and dropout, while automatically adjusting batch size. Our training run were tracked using ML4 via DAX Hub, including configuration and performance metrics. For the validation methodology, we split our data 80-20 for training and validation. For evaluation, we decode model prediction and compute both synthetic and semantic metrics. For the result analysis, we observed that the model performed well during deployment via Olama, producing coherent and relevant answers. Some local tests show issues like a mixed language output, likely due to the tokenizer handling or inference parameters. But this didn't affect the final version. We also applied the integrated gradient to identify which would most influence the model response. And this is a result analysis. For the model fairness, we skip fairness analysis for this project. The model focuses solely on answering investment-related questions in Thai and does not use sensitive personal data like gender or age, so fairness metrics weren't applicable. For the model versioning and experimentation, in model versioning, we ran 3 versions with different hyperparameters and manage all our experiments using ML4 integrated with DAX Hub. Each one logs important information like a learning rate, LoRa config, metrics, and runtime. Although ML4 doesn't yet support automatic PEFT tracking, we manually save each adapter. For the final model selection, out of all runs, the best model was from this run ID. Is used this base config and this is the achieve top performance. For the model explainability, to make the model interpretable, we use integrated gradient or the IG at the embedding layer. We processed token level attribution with the custom wrapper to visualize the importance of each token in a prediction. But due to the limited resource, we use only one step of IG, so result may be noisy. For the visualize feature important, we created a bar chart to show how each token influenced the model answer. For the explainability result, token right, revenue, trend, list were often among the most influential. This confirmed that the model is learning to focus on meaningful financial terms. However, attribution resolved with only one IG step should be interpreted cautiously. For the prediction listening, instead of using SHAP, which is low for the large model, we continue using IG. We reuse the same token attribution chart to explain how the model reached each conclusion. For the example output, we test the model with real query and visualize the listening. In notebook environment, some error occur, but in deployment via Olama, the model behaves correctly. Each example shows the generated output, top 5 influential token, and a chart to support interpretability. And here is our example output. For the model deployment, we deploy our model using Olama, a lightweight local LLM inference engine. It exports a RESTful API and supports real-time, multi-turn conversation. This setup enables smooth integration with the front end via single API/chat endpoint. For the validation, we validate the API using the Postman. For the scalability consideration, while development use Olama, our production plan is to use the serverless VLLM for better scalability. Next is the section 2, the UI model interface. For the front end, we use OpenWeb UI. It offers a modern real-time chat interface, multi-turn conversation support, and easy-to integration and feedback collection. And our system integrates OpenWeb UI built-in feedback system. User can rate each AI response on the scale from 1 to 10 and select reason for their score. This helps us track how useful, relevant, and accurate each response is, guiding future fine-tuning and improvement. When the user sends a message through the UI, it creates a JSON payload for the API/chat endpoint, and once the model generated a response, the API returns a structured result. And we also implemented the detailed early handling here. Next is the interaction flow sequence diagram. When the user sends a message, the UI wraps it into a request payload, and then the model processes and replies. The response is displayed along with the feedback tools. This ensures a smooth flow from input to insight. Our application is built on top of the OpenWeb UI, a full-stack open-source platform for the LLMs. We enhance it by adding custom tools, allowing the model to call functions. And here is the first scenario. The first one is the stock price 10 visualization with the technical indicator. The second one is the IAA consensus sentiment analysis. And the last one is asking the model to add the technical indicator. And for the challenge and solution, the first challenge is the best model of the Quen was pre-trained on Chinese. which caused it to sometimes respond in the wrong language. And the solution is we fine-tune it with the Thai data and add a strict system prompt to enforce the Thai language response. The second challenge is to calling require precise alignment between the model schema and Open Web UI interface. And the solution is we updated the model prompt and schema to match the Open Web UI expectation and ensuring seamless tool integration. And that's all for our slide presentation.
Here is our repository. So let's start with the README first. So in the README, we have included the members, the project structure with short descriptions of how the project is structured. We have the prerequisites or the applications or tools that you need before running the project. We also include the model setup to allow you to set up the model in Ollama. Then the installation instructions for you to install and set up the model in Open Web UI to use it in the actual applications. And in the last section, we have included the fine-tuning instructions to, if you want to fine-tune or try the notebook by yourself. However, you should be using the GPU cloud instance with the NVIDIA A100 as a GPU instead of your local device because of the computational resource required for fine-tuning the model. And next, let's go to every files in our repository. Let's get through each file in our repository. The first folder that we want to explore is the datasets. In this folder, we have included the VIIV sample dataset.json, which is the sample dataset that we have created for this proof of concept. The next folder is fine-tuning. In this folder, we have included the VIIV fine-tuning.ipynb, which is the notebook that we used for fine-tuning the model. This notebook also includes the inference of the fine-tuned models and the model explainability, like using the integrated gradient. And in the next folder, the model folder. In this folder, we have included the LoRa run, which is the final model that we have selected for this proof of concept. So in this, it includes the LoRa adapter that have been fine-tuned already, along with the tokenizers and required files. Next, we also have the model file, which will be used for merging the base model and the LoRa adapter together in Ollama. We have also included the system prompt that will be used to set up the prompt for the model in Open Web UI. And the last file is VIIV adapter.gguf, which is the converted adapter that can be merged with the base model in that used in model files. And in the next folder, the folder tools. In this folder, we have two tools. The first one is the interactive Thai stock analyzer with technical indicators tool. And we also have the Thai stock analyst consensus tool. These two tools are used as a function that the model will be calling in the Open Web UI to gather the information, the stock information from our sources. We also have the git ignore file, which is the files that will be ignored, and the readme and the requirements.txt. However, this requirements.txt is not intended for direct usage because the VIIV fine-tuning.ipynb notebook already contains the installation cells for these packages due to the specific sequential installation order required in the notebook. Next will be API demonstration using Postman that interact with Ollama and the model. In these examples, we send post requests to the Olama in the path of API/chat with the model name, the row-based messages, and the stream setting. The first example, I'll ask the model about the buying signal using MACD of the delta stock, along with the context of the MACD value for this stock. Here is the response of the model. It said that the MACD value is higher than the signal line, which indicates positive momentum with an uptrending potential. In this example, I asked the model about the business strategy of CPO along with the context that it needed. Here is the response of the model. It said that the company has a sustainable business strategy that focuses on the customer, and the answer is correctly match the content or the context given for the model. In this example, I asked the model about the source of income for PTT and provide it with the needed context. And here is the response of the model. It correctly summarized the information from the context. That said, the largest source of income of PTT is from natural gas, followed by oil and petrochemical. In this fourth example, I asked the model about the long-term strategic goal for AOT, along with provided the context needed for the model. And here is the answer of the model. It correctly summarized the information from the given context that AOT will expand the infrastructure of the airports. In this last example, I asked the model about the financial status of Advance or AIS and provide it with the needed context. And here is the response of the model that said the company has a very strong financial status with growth income and high profit that match the given context. And that would be it for this video. Thank you for your attention.